So let's move on to linting, which is, I think, the last, not the last correctness lecture, but it's one of the last main ones, and it's the tail end topic of static verification as well. And the 3.3 lecture where we talked about TypeScript was all like a very complex type of static verification. It was about like this TypeScript language that will go and check all the types are the same, and it's a very complex program. Whereas what we're actually talking about in this lecture is how to fix style, which is considered, as far as I'm concerned, a type of static. Bit rich to call it static verification, but it's a way of statically checking your code. It's a way of statically making sure that your code is correct, that it's written correctly. You know that you can have style guides that tell you how many spaces should be here or how many spaces shouldn't be there. But one thing we can do to make our lives easier is to automatically, in an automated way, means the same thing, style your code. And we're going to be talking about this topic called linting, and then we're going to be talking about something called Eslint. So, firstly, programs must be written for people to read. That's really important. Code is for humans. Code is not for computers. You don't get points for making code confusing. The computer does not give you a high five when your code when your code looks complex and confusing. But humans love you for it when your code's easy to read, and that's why we write code, for other people to read it. So we care about style. Why do we care about style? You already know style is important because you've done 1511. When code is consistently white-spaced, it's really easy to read. It's easy to follow through it. When code follows certain accepted patterns, like for instance, you have a brace here and then a new line and then an indent, which are pretty common across industry, it makes it easier for you to visually glance at code and make sense of it from a distance. And it can also be easier to detect bugs, because if your code is well styled, you might notice bugs a little bit easier. For instance, if you know variables should always be written a certain way, you'll notice when one is there's a typo. So, we know this. Here is code on the left, bad style. Here's code on the right, good style. These pieces of code both do the same thing. What do we know? The one on the left has a whole bunch of problems. The indentation's all messed up. The variable names are really terrible. The function name is terrible. The for loop is broken up on multiple lines. It's just not very good. So we don't like that at all. And we need to try and figure out automatic ways to avoid this happening. Before we get into that, though, we need to ask ourselves a very philosophical question, which is, who decides on style? When you work on a project, 1531, with your friends, doesn't really matter, who actually sits down and says, yep, this is the style that we're going to use? Well, typically when I say a group, I mean your friends, a new company, when they decide what style of code they're going to write in a project, they honestly usually they go and pick a really popular one. And there's a lot of popular ones out there, right? Like if you Google, JavaScript style guide, you're going to see the big typical players, which are going to be, Google and Microsoft. They're all going to have one. Google JavaScript style guide, a few random websites, Airbnb's style guide. There's some big companies. GitHub's style guide, it looks like. Oh no, that's Knees. Anyway, it doesn't matter. Point is that people do this for you. You don't sit down and decide it. You typically pick one. But then what you sometimes do is maybe change a few rules, right? So for instance, if you and your friends are like, you know what? We really, really hate camel case. We hate camel case so much. We're going to go and use snake case or something. Then you might go and change that. In 1531, we, the staff, decide on the standard styles and we provide them to you. So you're not picking them in this course, but that's kind of how styles decided. Linting is the purpose of this lecture. We're talking about linters. Linters are essentially programs that enforce style, right? In early computing courses, sometimes you're given a style guide and told to manually go and edit your code and clean them up to make them make sense. However, in actual software engineering projects, we tend to do what we call linting code, which is where we use software that statically looks at your code, as in it doesn't run it, it just looks at the source code, and it automatically cleans it up for you. And we call these programs linters, and we can loosely consider them another form of static verification in part. RJ asked a question in the chat, which is, I've noticed a nearly exclusive use of for loops within 1531. I find the logic of while loops easier to comprehend and use. Are there negative connotations for while loops in this course? So, firstly, no, if you use while loops in this course, that's okay. That's that's up to you and your group. While loops, for loops, doesn't really matter. I would say that most people would find for loops easier. I'm not saying that they're right or wrong. That's just probably what you'd mostly find. And therefore, that's just what we tend to do. But, I have had students who've said that they prefer while loops. They think they're easier to read and stuff. And I don't have an opinion on it, right? Like, there's no decision on it, so to speak. But generally, people find for loops easier. But either is fine, and it just depends on what your group wants to do. I don't want to say you or whatever, because, you're working with other people. But if a group was like, we're going to use while loops, to be like, sure. So what exactly does a linter do? So we know that static verification is the process of analyzing as much of your program as you can before running it, right? So a linter is essentially something that does static analysis on your code. And what it checks is it checks for two things, which is style issues, which are things like white space and indentation. And it also checks for what we call semantic issues, which are basically potential bugs. Linters are nowhere near as powerful as Typescript when it comes to looking for bugs in your code, but they can pick up on some simple things, such as you using a variable that hasn't been defined anywhere, or you defining a variable that's never been used anywhere. So it can do some really kind of simple checks on your code. What linting doesn't do is help with things like your variable name is confusing. Because a computer doesn't know what variables mean, right? A computer just looks at variables and is like, all right, that's a variable. It doesn't care. It's all just memory to it. So, when we see pieces of bad code like this, whilst linters can help with things like potentially undefined, variables that weren't defined or indentation, it won't tell you that A, B, and C are terrible variable names because it just doesn't know better. So linting really helps out with that. Now, the tool that we use in JavaScript, and there's different tools for different languages and different frameworks, to lint our code is called Eslint. The ES stands for ECMAScript, which is the language standard that JavaScript's written on. Doesn't matter why it's called that, but Eslint is basically the JavaScript linter. It's a popular external tool for statically analyzing JavaScript code, and what that means is that external tool is you have to npm install it. It's not built into Node. You actually have to install it. So it can detect errors, warn of potential other errors, check against conventions, and it can also fix your code automatically. And to Alex's question, will Eslint work with TypeScript? Yes, and it took some configuration and a bit of headache sometimes to make it work. That's what we mean about, all the TypeScript in this course. We have gone through quite a lot of efforts to figure out how to be able to get your project to work with it such that it just works for you. And we do a lot of that pain. So that's why you kind of see these random files and configurations existing that we tell you not to worry about, because we go and, make those for you. But yes, it will work for you without any problems. So how do we use Eslint? Well, let's go and play around with it. So let's imagine here that, let me get rid of this window. I don't think, we might go a few minutes over tonight, just as a heads up, but this is a really short lecture. It looks long, but it's really not that bad. So just prepare yourself for 5 minutes over or something. But let's close some files here. So if I wanted to use Eslint in my program, I would simply npm install it, right? Eslint, just like that. And it would install itself into my package.json. I've already installed it here. It would come up as a dev dependency like that. Would be really simple. And then I could go and make some code if I want to. So I'll go and make a really simple, stupid one here. I'll go make a new file called badcode.js. In fact, I don't even know why I'm doing that, because I already prepared some examples. That's why we had stylebad.js here. So I can go and install Eslint like that, and then I can go and run the linter. However, the way Eslint works is it doesn't just have this built-in idea of what is good and bad code. it actually looks for a particular file, which is defined as .eslintrc.js. And you'll see this file floating around the labs and stuff that we push you. I'm just looking for it. I think in the lecture code, it's put in I put it in a slightly different spot. So I might just have to grab it quickly. Again, lecture code's set up a bit weird. But in your projects, it's sitting in the root directory, just like your .gitignore and stuff like that. Just let me look for it. 2 seconds. Okay, I found it. Yep. All right. Okay. I hadn't included it, but let's include it here. So there's basically a file, and that file is .eslintrc.js. Right, and it can be a few different things, but in this case, it's a JS file, a JavaScript file, and this is essentially the instructions to Eslint as to how to determine whether you're like what's good style and what's bad style, because Eslint doesn't have an inherent view of that, right? Eslint's looking for instructions. So now that I've got that file, and again, you don't need to know what's in this file. It's just a lot of stuff. It says things like, okay, I'm trying to look at one that might make sense to you easily. Okay, no duplicate keys. Basically, it's like, hey, if someone goes and defines an object and says const a equals width 8 and width 9, that's bad. Don't do that. You know, that's kind of like, I think that's what that means. I'm not 100% sure, but like this is the kinds of things the linter's checking for. It's trying to like make sure your code is like pretty clean. So we can actually go and run that by running like we have with Jest and like we have with TSC and TSNode. We can go and run a node modules binary, this Eslint thing here, on that particular file. So I can go node modules.bin.eslint and I can run it on source/3.4 style bad. And let's see what it does. Oh no, it's complaining. Or I think this might have to be a... Yep. Okay. So I've got some... Also, this Eslint file, Kai's posted something in the chat. The Eslint file can be both JSON and it can be JavaScript. We tossed and turned about which one we want to use. They both look nearly the same. You can also do it as a YAML file. Eslint's pretty relaxed. You'll see here that when I've tried to run Eslint, it's actually gotten really mad. It's actually said that we're currently running a version of TypeScript that's not supported by blah, blah, blah. My current TypeScript version is this. The TypeScript version we have is too new, so it's like complaining. This is one of these examples of problems you actually will come across in like large software projects that you're probably not likely to come across in the course. I'm going to try and change the version here, see what this does. So I'm going to my package.json here, and then changing the version, and I'm going to go and try and npm install again, and that should hopefully pick up the new version and install an earlier version of it. I don't know if it will. No, it still didn't like that. That's not particularly good. That's very concerning. I'm not too sure how we could do that. Sometimes if you have big problems with stuff in Node, you can go and delete your whole Node modules folder, and you can go and npm install things again. And when you npm install things again, it will hopefully solve problems. Sometimes not. A bit worried. Yeah, so let's dissect this. It's really quite saying, like literally, it's saying that we have a version of TypeScript 4.7.3 here, and the Eslint only works with TypeScript's version 3.3.1 to 4.7.0. And I kind of look at this and I think, I have absolutely no idea why this is a problem. And sometimes these things can get really tricky because where TypeScript's defined in a whole project can kind of be all over the place. And in this particular case, I'm not 100% sure why it thinks there's a 4.7.3 version when we've gone and fixed it up. Sometimes we could try and go to an earlier version like this. You could just kind of pick a random version, see if we delete the node modules folder again, reinstall it. Sometimes it's also complicated because what happens is, whilst the TypeScript version you're using here might be 4.6, you might actually have another library that's using a different version of TypeScript that, that's using a different version of TypeScript that essentially is using like a newer version and stuff. And this is where in the NPM lecture, oh my God. You can see here it's actually trying to do some, this is it kind of getting confused. So Kai pointed out correctly. Remember how in the NPM lecture we talked about these little hats and these little like tildes, how they mean like approximately and up to this version and stuff. And now you can see it's kind of basically saying I couldn't find version of TypeScript version 4.6.0. How do we find an older version? Well, obviously I could just type in 4.7.0 here, but if you're not sure, you can always just go to like the npm.js website, right? And you could just look up TypeScript. And you can actually see all the versions that exist. And I'm sure if you look here, you'll probably see there probably wasn't a version 4.6.0. So when I just randomly put that in, it was just like, click, 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 click. It just probably was like that version doesn't exist. Yep, let's go down. You'll see like version 4.7.0. Yeah, there was just version... Well, there was a version 4.6.0, but it... Yeah, there was never like a... It all had these weird different things. So it just didn't exist. So if we try 4.7.0... My throat's hurting. These are things that real developers bash their head against all the time. It's actually one thing I really hate about... We often... See, you might be sitting there thinking, God, this is annoying. 1531, it sounds so complicated. But the problem is that the stuff you kind of do in 1511 and whatnot, and even 2521, you'll never experience that in your life ever again, where you just get this empty file and someone says, go write a C program. And you go ask someone who's worked an internship or has a grad job, they'll tell you that they'll sometimes spend all day getting errors like this and just Googling it. You know, trying to figure out what the hell actually has gone wrong, for instance. And like, it's particularly tricky for me right now trying to, you know, run a lecture that's towards the end. But basically, I'm imagining what's happening here is that whilst we've changed the TypeScript version, there are other libraries that are probably relying on... Let me try also deleting the package lock.json. I don't know if this will work. No, it got really mad at me too. Oh, I'm just trying things at this point. Normally I'd think about it deeper. It's actually very hard to think very deeply about things when there's many people watching you. So we'll see how this goes. This is kind of a problem because all the lecture code that I have, it's all running in the same little npm project. So there's a lot of like conflicting things here. Whereas, for instance, if we just kind of started this again, for instance, it would be pretty okay. And like, I'll try and show you that. For instance, if I just, I could try and pull some of these things out, but I don't really want to. No matching version found for my TypeScript. Is there no 4.7.0? Oh, okay. Let's try, oh, is it there? Maybe that version doesn't exist. Maybe I've been really dumb. Let's try a version that does exist. Maybe 4.6.3. See if this solves the problem. Maybe I just had the wrong version. Read your errors. It kind of says it right here. No matching version for TypeScript 4.7.0. So maybe this will work. Okay, there you go. So the problem was that, in summary, one of the libraries said, whoa, you have a really new version of TypeScript. I have no idea how to work with that. I'm not going to work with it. So he said, fine, we'll downgrade it. We'll change the version to an older one. And we did that, but I changed it to a version that didn't exist. That was the whole problem. Really simple. So let's go all the way back now. And let's try and actually ESLint our code. So we installed ESLint. And we'd now like to ESLint our bad code. Why is that empty? Oh, that's the random file. Let's go find our bad code, lecture 3.4, style bad. So we go and run ESLint on that. And it will complain. Should complain. I don't know why it's not complaining. That seems particularly strange. Oh, ESLint disabled. Kai's on top of this. So for a lot of the lecture notes, I actually lint the lecture code so that all the code follows the same style. But the problem with that is that when I show you examples of bad code, if I include the bad code in the lecture code, my own systems complain and they say, Hayden, your lecture code is really ugly. You need to fix it. So I included this little keyword up here that tells ESLint to ignore problems. And that's why it ignored the problems. But when I remove it, and thank you, Kai, when I remove it, you see that it starts complaining. It says things like, a space is required after a comma. You're missing a space before an open brace. There's expected 2 space of indentation, but they only found 1. They expected 2 space indentation, but they found 3, right? Like there's all these different kinds of errors that come up. And all of these different kinds of errors are defined in this ESLintrc file that we give you. So that's where they all come from. Now, just like Jest, just like tsnode, and just like tsc, I can go and put the eslint command, right, inside something like this, where I write lint is eslint source/*.ts. Now, I might get rid of this for the moment, but essentially what this means is that instead of running this command here, I can run npm run lint, and then I can check my code as well, stylebad.js, like this. And that will go and check the code. So that's pretty useful there. So I can go and, clean all that up. One thing that's super exciting about ESLint though is it has a very, very powerful --fix command to it, where what happens is when I run it, after I do the lint, if I also add a --fix here, what it will do is it will actually fix my code for me automatically. So if I've got this ugly code here and I run this, it will not only find the problems, but where it can, in this case it didn't, I need to put that, let me put that command in a different spot. I need to put it inside my package.json here. So I need to put it here. So you see now I'm running eslint --fix, and when I run this, the --fix will tell people to fix the code. And you see how that cleaned up the code? In fact, it got rid of all the errors. Some other weird things happened along the way, like you'll notice that the for loop here went down here. There are some things that ESLint doesn't care about. Like, you probably wouldn't do this. You could add rules to ESLint if you wanted to that would prevent that. Like, that code looks okay. And if I run that, ESLint's like, yeah, cool, it looks good. It doesn't like that I've mixed tabs and spaces. You'll see here I tabbed that in when I shouldn't have. But if I turn that to spaces, it's fine. And it says there's that unexpected tab character, but it will figure things out, right? Like if I indent that and I run the lint, it will go and fix it and move it back for me, right? And if I go and, add a whole bunch of empty new lines to the program, it might go and remove them for me and trim that down, right? So it's very, very powerful, right? Super, super, super powerful. That's what it can do. Sometimes though, thanks for your patience as we run slightly over time tonight. We had a short lecture yesterday, but sometimes we have code that we know breaks the linter, but we don't think we can do anything about it. Like we don't think we can fix it. Like it's just it's just how it has to look. This is particularly true when you steal code from the internet sometimes, and that code doesn't match the style guide, but you don't know how to do it any other way. In these few cases, you can actually add a comment to your code, which is eslint disable next line, where if you put that comment above a problematic line of code, like this one here, which is clearly not good, if you put that there, then what will happen is that the linter will ignore the next line. That's how the linter works. So when it looks at your code and it sees this comment, it will ignore the next line and it won't change it. You shouldn't be using this in your projects. And again, this is all for iteration 2. right? This lecture is all for iteration 2. It has nothing to do with iteration 1. But it can be used sparingly. If you use it once or twice in your project, that is totally fine. There's no issues with that at all. When you insert it into your project, you can use the commands we give you here to basically lint all your files. So you can add a lint and a lint fix command, and you might notice that there's all these little */*.js things. Whether this is TS or JS, it doesn't matter. Like, it depends what you're linting. But what these basically do is these go and lint all the files. So for instance, if I go back to my package.json and I have this here, right, what this source/**.js says is that when I run the npm run lint command, instead of giving it a specific file to lint, go and lint all the files in my source folder here, .js. So it will go and lint all the .js files that exist inside that source folder, which are these files. So if I just run npm lint now, it will go and lint all those files. And this is really useful for your project because it will go through and it will point out all these problems with the different files. And then if you run, for instance, lint fix, which is another command we ask you to add, it's the exact same command, but with the -- fix thing. What will happen is that it will go through and it will fix everything. Literally, it just went and fixed all those files for me. It went and cleaned them all up, which is really, 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 really useful. So very, very powerful there. The other cool thing about linting is that you can add it to your pipelines as well. So when we did talk about pipelines on Monday in the CI lecture 3.2, we talked about lots of other things you could add to it, and linting is just another step. So you can lint your code, you can type check your code, and then you can test your code. And you can see what we're doing here is we're finding methods and we're layering them on and we're building them up to try and find ways to give you more confidence that your code works. And this is really, really useful because this means when you push to GitLab, you're not having to stress, is my code clean? Is it type safe? Does it work? All of this is handled for you. A lot of this is just about sleeping easier. So Eslint will be part of your labs from week 4. We will give you the configuration files and add lint to your package.json. We will do everything for you. It's from your labs next week. Eslint will be part of your project in iteration 2 onwards, which is week 5. So you'll see it appear with the configurations and everything will be done for you in week 5. Right, so again, you don't need to stress. We do it all for you. We give you the commands. We're very, very, very helpful and hand-holdy with this. You don't need to worry about it just yet. All the examples that we gave in the lecture were for JavaScript. To get Eslint working with Jest and Typescript, you do need to run a few extra commands. Again, these are all things that we add to the project for you. So you don't need to do it. We do it for you. This is all just background. This is all just theory for you. For Jest, we have to install another module and we have to add this particular line to the ESLint.rc file. We again do that for you. This is just background so you know how it works. And with TypeScript, we have to add this stuff to the ESLint.rc and we have to go and install all of these modules for you to make that work as well. And so we do it all for you. These slides are here to just explain to you what we do because we don't like just changing stuff and being like, forget about it. Don't worry, you don't need to know what changed. We'd rather be like, this is what changed. You don't need to dig any deeper, but you can if you want to. And that's why you'll notice that in this project, you remember that if you ever had a look at the package.json, do you notice all this stuff here? Most of this stuff here, I'd say about half of it is just to get TypeScript and linting and all this kind of stuff working together. And we can go and ESLint the TypeScript files now, in theory, assuming I haven't made a mistake here. So if we just change this to .ts now, our linter should be able to go and lint our TypeScript files. So when I say npm run lint, it will go and lint all of these files, all of my TypeScript files. Let's see if it works. It might not because there's been a few hiccups tonight. No, it did it. It did it fine. It looked at my files. It said here, okay, so in my example functions file, one of the early ones we looked at in the previous lecture, it said new line required at the end of the file, added. So that should disappear now, right? See how we've got 1, 2, 3, 4, 5? If I run it again, it'll only show me 4 files. 1, 2, 3, 4. And then I'll see the same thing for the list file here. Add it to the end, and then it should only show me 3. So now I only see 3. And if I run the fix command, it will go and fix them all up for me. So now they're all fine. Really easy, right? You don't want to run the fix command in your pipelines, because all that will do is fix the code, the copy of the code the runner is running. It won't actually change your code on the repo. So you run the fix locally, but the pipeline runs the other one. I already talked about this. I'm not exactly sure why this is in the lecture twice. I guess I included it twice without realizing. Okay, that's good. I know I can take that slide out. That's unnecessary. Yeah, and as Kai said, you don't need to count the errors. It tells you on the terminal. I was just showing you. So like here it shows you 4 problems, 3 errors, blah, blah, blah. It tells you everything you need to know. And again, don't stress. I put this in 2 lectures because I wanted to emphasize it. So this brings us to the end of the linting lecture. And I know I've said this a few times tonight, and I know I like to repeat myself, but I just want to point this out. The way these lectures are sorted out is that there's a big dump of new concepts, particularly in 3.2, 3.3, 3.4, as well as 2.1 and 2.3. And they're all to do with dependencies and jest and TSC and TS node. Sorry, my throat's really dry. And the linting, and it feels like a lot again, but I just want to say for the 100th time, there's a lot of new concepts here, but just like when we first learned about Git, we talk about today, you'll go and do it next week, the week after, you'll settle into it. And to be honest with you, most of the tail end of the course is actually just theory. Like pretty much all of, like nearly most of this, pretty much from the middle of week 5 onwards, we're nearly just doing theory. So there's a lot of programming at the start of the course. So don't stress. I guarantee you it's super easy. Thanks for your patience tonight. As we've talked about a few fun things, if you're feeling worried or anything, you can go chat to your tutor. And most importantly, everything in this lecture is not used at all until week 4 and not until week 5 with your project when iteration 2 comes out. So you have an absolute bundle of time to get comfortable. And I promise you we wouldn't be talking about this stuff if it wasn't interesting and valuable for you. So please go have a good evening. It's really nice to see everyone here. I'll email you all on Friday and see you next week. Should be fun. Looking forward to it. A lot of fun content coming up. Congrats for everyone who finished iteration 0 and got that sorted. You did a good job. And good luck with starting iteration 1. Your tutor's very helpful. Please go lean on them as you need to.